Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah. This is Stat 101, Major 2, Term 232. Let us have a look to the exam and solve it together. The first part, multiple choice questions, 6 questions. First one, the first card selected from a standard 52 card deck was a king. You know, in a 52 card deck, how many kings are there? There is a king from each suit, so there are 4 kings. So we selected a card and it was a king. If it is not returned to the deck, if it is not returned, so how many cards left? 51. What is the probability that a king will be drawn on the second selection? Now, how many kings left? We selected one in the first and we did not return it. So there are 3 kings left because there are 4 kings in total at the deck. So that's the answer, 3/51. A bank has found that the daily balance available in its saving accounts following a normal distribution, okay, with a mean 500, so that's the mean, 500. And standard deviation of 50. This is X normal distribution. What percentage of the saving accounts holders who maintain a daily balance of more than 500 Saudi riyals? More than 500, يعني this, يعني probability that X is greater than 500. Well, we know that this is a normal distribution, symmetric. The total probability is 1, the total area is 1. So the probability here is 0.5 and the probability here is 0.5. So the answer is 50%. 0.5 as a probability, 50% as percentage. Chances are 50-50 that a newborn baby will be a girl. So probability that it's a girl is 50% or 0.5. For families with 5 children. So this is an N, 5 children. What is the probability that all the children are girls? Well, you can think of this problem as binomial distribution with N is 5 and he is asking about girls. So the probability of girl is 50-50.5. And he is asking what is the probability that all the 5 children are girls. So what is the probability of 5? So using the formula of the binomial distribution, N is 5, X is 5, P is 0.5. We raise it to the power X or 5 times Q, which is 1 minus P, which is also 0.5, to the power 5 minus 5, which is 0. Well, this is 1 and this is 1. So the answer is 0.5 to the power 5. If you put it in the calculator, it would be 0.03125. So the answer is B. Or you can just think of it, the probability of one girl is half. So the first is half, all are girls. So the first is half, the second is half, the third is half, the fourth is half, the fifth is half. So in fact, the probability is half to the power 5, which is this one. So it's up to you, but the same answer would be in both cases. At King Khalid International Airport, on an average, 30 flights land per hour. Per hour, so this is Poisson distribution, and this is lambda, and the segment here is hour. So T is in hours. If the flights pattern follows by, okay, Poisson distribution, then the probability that no flight, so he's asking about the probability that no flight, which means number of flights is 0, X is 0, will land in 30 minutes. 30 minutes. He said per hour. So T here is 30 minutes, means half a segment. One segment is 1 hour. 30 minutes, half an hour, or half a segment? Well, the formula for Poisson distribution probability of x is lambda t to the power x e to the power negative lambda t over x factorial. So x here is 0, lambda 30, t is half, so lambda times t would be 30 times half, which is 15, to the power 0, x is 0, e to the power negative lambda t, which is 15 over 0 factorial. 0 factorial is 1, 15 to the power 0 is 1, so the answer is e to the power negative 15. A binomial distribution is an example of course, the binomial is not continuous, sorry. The binomial is discrete distribution. Binomial, discrete. Poisson, discrete. Normal distribution, continuous. If two events A and B are not mutually exclusive. Mutually exclusive means like this. So not mutually exclusive means there is an intersection. Okay? There is an intersection. This is mutually exclusive, no intersection. Not mutually, so there is an intersection. What does addition rule state? Well, addition rule finds the probability of A or B, union B. So it can't be B and C. A or B, it is not negative. The formula is probability of A or B, probability of A plus probability of A minus probability of A intersection B. That's the correct answer. If A and B are mutually exclusive, no intersection between them, in that case, the addition rule will be probability of A plus probability of B only, because the probability of the intersection would be 0. But here, there is an intersection, so that's the correct answer. So let me erase this. A car dealer has 6 Ford cars, 3 Mercedes, 5 Toyota. If 2 cars are to be selected, so how many cars in total? 9 plus 5, 14. Okay, 14 cars. 2 cars are selected without replacement. Okay, so we'll select the first one and we will not return it. We will keep it with us. What is the probability that both cars are Toyota? Let us think of the first car. First car, what is the probability that the first car is Toyota? How many Toyota are there? 5. Out of how many of 14? So this is the probability of the first car. And what is the probability of the second car? And we need the first and the second, so we multiply. The second, we need it to be Toyota. No replacement, not replaced. So the number of cars now is 13, not 14. And the number of Toyota cars is 4 because we already selected one Toyota in the first. So this is the answer. If you just find it, you can leave it like this. You can write it as 10 over 91 or just 0.11, approximately 0.11. It's 20 over 182, then it would be 10 over 91 or 0.11. Okay. First car is Ford. What is the probability that the first is Ford? We have 6 Ford cars out of 14, so that's the probability. And so multiplied by the second car is Mercedes. How many cars are left? 13 because of no replacements. If it is with the replacements, then always the number would be 14 here, and it would be 5 over 14 here. So Mercedes, we need the second one to be Mercedes. The number of Mercedes cars are 3 because we did not select Mercedes in the first, we selected Ford. So it remains 3. The number of Mercedes cars remains 3. So the answer is 9 over 182, or if you want to write it like this. Sorry, it is 3 times 6 is 18. We are multiplying. So 3 times 6 is 18 over 182. So the answer is approximately 0.1. Okay. I just want to check if something. Okay, correct. So everything is fine. Both are Mercedes. Okay, we have 14 cars. How many Mercedes? Three. This is the probability of selecting that the first car is Mercedes. Now the second is also Mercedes. We have 13 and we have two left because we selected one Mercedes in the beginning, in the first time. So now 6 over 182, or just it is 0.033. Okay, suppose that a population is normally distributed with mu and sigma given. Find the probability that a value randomly selected from this population will have. So he's asking about the probability that x, which is the normal distribution, is between these two numbers. To find this probability, you have to change it to z. Z is x minus mu over sigma. So x is 93. Subtract from mu, which is 100, over sigma, which is 10. Less than x minus mu over sigma would be z. We are in z now because we are using this equation. So 111 minus 100 over 10. So you will have probability of what? This is -7, so I'll have -0.7. And this is 11, so I'll have, there is a z here, and 1.1. So we need to find the probability that z is between -0.7 and 1.1. How can we find this probability? Well, this is the distribution, the graph of the z distribution. This is z. This is 0 here. 1.1 is somewhere here. -0.7 is somewhere here. We need to find this area. Well, in the table gives this area only, not from here to here. So the table will give me the probability from 0 to 1.1. So I can write this probability of from 0 to 1.1 plus the probability from 0 to -0.7. But there is no negative in the table. But probability from 0 to -0.7 is equal to the probability from 0 to 0.7 because of symmetry. So we just go to the table and search for 1.1. This is 1.1. So 0.3643. And 0.7, this is 0.7, 0.258. And you add these two probabilities and write the answer by the calculator. It's 0.6223. What is the probability that x is greater than 100? Similarly, you change it to z by subtracting minus mu over sigma. So this is 20 over 10, which is 2. So what is the probability that z is greater than 2? Well, here, this is the graph. This is z. This is 0. This is 2. And he needs this area or this probability greater than 2 to the right of 2. Well, I cannot find this from the table. I can find this from the table. The table gives this area only or this probability. But I know that the probability to the right of 0 is 0.5. So the probability of z greater than 2 would be 0.5, the total probability to the right of 0, minus the probability from 0 to 2. And I can find the probability from 0 to 2 from the table. Because look, from 0 to 2 is given here. So 2, where is 2? This is 2.4772. If you subtract by the calculator, you will find that the answer is 0.0228. Use the binomial formula to calculate the following probability for an experiment in which n is 6, p is 0.3, the probability that x is at most 5. What is the meaning of at most 5? At most 5. Yani not greater than 5. Yani the maximum is 5. So it should be less than or equal to 5. This is the probability he's asking about. At most 5 means less than or equal to 5. Well, n is 6. So x runs from 0 to 6. And I know that probability of 0 plus probability of 1 plus up to 5 up to 6. Sum of all of these probabilities is 1. He's asking less than or equal to 5. So he's asking about all of these probabilities. Why should I find all of them? I just write it 1 minus probability of 6. That's it. And I use the formula once. So 1 minus probability of 6 NCX will NCK can be written as NK like this, okay? So I'll use this notation. N here is 6. X is 6 because I need to find P6 times P, which is zero point 0.3 to the power 6, which is X, times Q. What is Q? 1 minus P. 1 minus zero point 0.3 is zero point 0.7 to the power 6 minus 6, which is 0. This is 1, and this is 1. So the answer is 1 minus 0.3 to the power 6. That's actually the answer. And if you put it in the calculator, it would be 0.999271. So probability of 6 is very low, very small. So having X probability of all of them, yeah, this is the total of all of these probabilities. So it's high. A company is studying the number of monthly accidents. Okay, so this is the number of monthly accidents. This is the probability of each one of them. The total probability, if you add all of them, you should get 1, 791. Okay. What is the expected number? The expected number is mu, and it is summation x px. So we multiply 2 times 0.4 plus 4 times 0.3 plus 6 times 0.2 plus 8 times 0.1. And we add all of them, and the answer is 4. So mu is 4. Now, how to find the standard deviation? Well, sigma, the formula says sigma is square root of summation x minus mu squared multiplied by probability of x. So it's square root of x, these values. These are the values of x. So I subtract 2 minus 4. That's negative 2. Square it, it is 4. Multiplied by what? By 0.4, which is the probability of 2. Okay, now what about 4? 4 minus 4 is 0. That's it. 0 times the probability is 0, so I'm not worried about this 4. 6. 6 minus 4 is 2. Squared means 4. Times what? What is the probability? The probability is 0.2 plus 8 minus 4, that's 4. Square it. 16 times the probability, which is 0.1. Put it in the calculator. You will find that the answer is 2. You can answer this question using I mean, calculator. Go to mode 3, mode stats. Mode stats. Then press stat, press 1 variable. And the frequency should be there. If the frequency is not there, put it. So there should be X and frequency. How to put it? In using shift mode. Shift mode will give you frequency. Shift mode, go down to stats, press stat, he will ask you frequency on or off, put it on. Put X 2, 4, 6, 8, and put the frequency as the probability. And then press on, okay? And then go to shift plus 1, which is stats, written here, stats. And if you press shift stat, you go to choose number 4. which is variance. And if you press number 4, you have x bar. So number 2 is x bar. This will give you mu, which is 4. And number 3 will give you sigma x, which is 2. So you check your answer. You may check your answer using this method, the calculator. In an emergency department of a hospital, a doctor expects an average of 11 patients in 30 minutes. So this is a Poisson distribution. Average 11, that's lambda. The segment here is 30 minutes. Okay. Assume the number of patients approximate a Poisson. What is the probability that at least one, at least one, at least one? So 1 or 2 or 3, so x is greater than or equal to 1. In Poisson, I cannot find x greater than or equal to 1 because I have probability of 0 plus probability of 1 plus probability of 2, and it doesn't stop. Not like the binomial, it goes to n. So to find probability of x greater than or equal to 1, it is enough to find 1 minus probability of 0. Okay. That at least one patient arrives in 15 minutes. 15 minutes, 30 minutes is my segment. 15 minutes is half of the segment, so t is half. And remember, probability of x is lambda t to the power x uh, times e to the power negative lambda t over x factorial. So it would be 1 minus probability of 0, so x is 0. Lambda t to the power 0. Okay, 11 times half is 5.5. I can write it, and I also don't need to write it because it's 1 times e to the power negative 5.5 over 0 factorial. Also 0 factorial is 1. So the answer is 1 minus e to the power negative 5.5. Use the calculator and you will find that the answer is 0.9959. Thank you for listening, and I hope you enjoyed solving this exam with me. Best wishes.